Hi geometry students. This video is a review of simplifying radical expressions. And so this is a topic from Algebra 1 that you should be familiar with, but just in case you've forgotten or maybe you never learned it, we're going to run through it today. So first of all, I want to go over something called the product property of square roots, which is kind of what we're using in order to simplify radicals. And just a kind of quick note, square roots and radicals and square roots were kind of the same thing. There's more radicals than just square roots, but for our purposes, you can think of them as being the same right now. So the product property says that if you have the product of two numbers inside of a square root, that will always equal the same thing as if you square root both numbers individually and then multiply them, as long as both a and b are not negative. So I'm writing a greater than or equal to 0, b greater than or equal to 0, which means basically neither of these two numbers are negative. Quick example. Suppose we have the square root of 4 times the square root of 25. Or sorry, the square root of 4 times 25. That will be equal to the square root of 4 times the square root of 25. And just a quick caution. This rule does not work with addition. Okay, so the square root of a plus b is not the same as the square root of a plus the square root of b. And we can see a quick example of how this definitely is not true. If I look at the square root of 9 plus 16 and think about what happens if I split that up, will these two things be equal? So will that be equal to the square root of 9 plus the square root of 16? Well, on the left-hand side, I would get 9 plus 16 is square root of 25, which is 5. But on the right-hand side, I would get square root of 9 is 3 plus the square root of 16 is 4. So I end up with 7. And 7 does not equal 9, right? So we can see how this is not always going to be true versus over here with multiplication, this will always be true, okay? So I'm going to show you guys two different methods for approaching simplifying roots. The first method, calling method 1, is to look for perfect squares. And just to remind you of what perfect squares are, so they are whole numbers that when we square root them, we get a whole number answer. So 1, when I square root 1, the square root of 1 is 1. 4, when I square root 4, square root of 4 is 2. I could also generate these numbers by just doing like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and I can kind of go up from there and get the first, say, 10 perfect square numbers. And these numbers are good to keep in mind because that's what we want to be thinking about when we do method 1. So my first example is going to be the square root of 50. And our idea is we want to figure out, is there a perfect square number that goes into 50? So our step here is to break down the number we see inside the root into perfect squares. And you could have more than one. So in this case, when I think about 50, well, I know if I divide 50 by 2, I get 25, and that's one of my perfect squares. So that seems like a good place to start. I always do like a little factor tree. That just helps me kind of visualize what's going on, but you might have a different strategy, and that's okay. So what does this mean now for our simplification? It means that this is equal to the square root of 2 times 25. And then the product property tells me I can pull that apart into the square root of 2 times the square root of 25. And square root of 25 I can simplify because it's a perfect square. I know that that's just 5. And square root of 2 I can't actually do anything with, so I'm going to leave the square root of 2 inside the root. So I end up with a 5, and I'm going to write the 5 from root 25 out front, and then I leave the square root of 2. Okay? So first we break down into perfect squares, and then our second step is to simplify. And this would be my fully simplified form, 5, and I would say 5 root 2. Okay, let's look at another example. My next example is the square root of 72. So I'm going to start by breaking this down and see if I can find a perfect square that goes into 72. Since 72 is even, I might start just by dividing that by 2 and seeing what I get. And I know if I divide 72 by 2, I get 36. And what do you know? 36 is a perfect square, so that worked out well for me. So now I'm going to break down the square root of 72 into the square root of 36 times 2. Pull those roots apart by the product property. And now I know the square root of 36 is 6. I can't simplify root 2 anymore, so I'm just going to leave it as root 2. And that's my final answer. Okay, so now I'm going to give you 2 you-try problems. So you can pause the video and try these problems before moving on. And then we will go over some solutions to these problems in class. So the first one I want you to try is the square root of 48. Try breaking that down. The second one is the square root of 125. So pause the video, try those out, then press play. Okay, so now we're going to do, I'm going to show you the second method. So method 2 is to pair prime factors within the number you're trying to simplify. And this is a good method when you can't think of a perfect square that goes into your number. So if you have a really big number or for whatever reason you just can't think of it. So I'm going to say when it's hard to find perfect squares. So I'm going to call this next example, example 3. And we're going to do, I'm actually going to do the square root of 72 again. I'm going to write a number out front because sometimes you'll see a number out front. We're going to see how we could get to the same simplification of square root of 72 in a slightly different way. Okay, so my first step here, instead of just looking for perfect squares like the previous one, I want to break down into prime factors. So I know 72 is 2 and 36, and then 36 I know is 6 times 6, and each of those 6 times 6's is 2 times 3. So then as my prime factorization, I'm just going to rewrite 72 inside, but inside of the root, I'm just going to put all of the prime factors. So that means 2 times 2 times 2 times 3 times 3. And I'm going to bring down that 2 that was out front. So the second step here is to group pairs of the same prime factor. So we'll say group factor pairs. So here I see I have 2 2's and I also have 2 3's. Okay? And the reason why we group them is because 2 2's is the same, 2 times 2 is the same as saying 2 squared. And 3 times 3 is the same thing as saying 3 squared. So the idea is I want to pair them so that I get to that squared, because when I square root something squared, I'm left with just the base number. Okay? Now I still have this one extra 2 inside the root, so I'm just going to write that one by itself and bring down the 2 out front. So now I know the square root of 2 squared is just 2. The square root of 3 squared is just 3. If I'm not sure, I could always do 2 squared is 4. The square root of 4 is 2. 3 squared is 9. The square root of 9 is 3. And then the root 2 stays inside the root. And I'm going to bring down that 2 out front. So I have 2 times 2 times 3 times the square root of 2. So my last step would just be to multiply all the numbers that came out. So I would get 2 times 2 is 4, times 3 is 12, so this becomes 12 root 2, and that would be my final answer here. Okay, I'm going to flip to the next page and do one more example. Call this example 4. And we're going to do the square root of 48. So once again, I'm going to start by making my factor tree, and I want to break this down into the prime factors. So 2 and 24, 2 and 12, 2 and 6, 2 and 3. And then I get all these 2's and 1 3. So when I write out my prime factorization inside the root, 2 times 2 times 2 times 2 times 3. Now I'm looking to pair two of the same factors. So I see I have 2 groups of 2. So from each of the pairs, 1 2 can come out. So, and I'll just kind of rewrite this just to show all of my steps. So this is the square root of 2 squared, the square root of 2 squared, and the square root of 3. So from the first square root of 2 squared, I get a 2. From the second square root of 2 squared, I get a 2. And then root 3 stays inside the root. 2 times 2 is 4, so my final answer is 4 root 3. So I'm going to give you guys 2 more U-tries, and I'll say you could use either method, whichever method you're kind of feel like you want to try out or you feel most comfortable using. You can use that method. So the first, so I'm calling this U-try C, square root of 450. And then U-try D is going to be the square root of 80.